Hello everyone. In this video, which is the first of a series, I'm going to talk about Scikit-Learn, which is basically a library, a module for doing basic machine learning in Python. So in this first video, I'm going to show you the popular and simple method of k-means clustering using Scikit-Learn. For that, you need two things from the Scikit-Learn. One is from the data sets, the method called make blobs to generate data, and the other one from Scikit-Learn cluster, which is doing for clustering task, the k-means method. So you don't need to bring everything from Scikit-Learn, just these two things, generate data and then clustering for k-means. I also need you to bring in the matplotlib for plotting, and then here I'm using some zeros matrix for the numpy, although you don't have to necessarily use it, but here are the initial importing that I have. Then you can have the number of data that you want to generate. So if you don't provide a number for this make blobs, how many data to generate, the default for it is 100 data, but here I want more data, so I go ahead with 1,000 data points. This function make blobs, in general, this can take lots of different inputs, and for most of them, it has a default value. So again, if you don't provide them, it is going to assume something. The next input is the number of features. So each data point, each sample has how many values, how many features. So this is the size of your feature space. For it to be easily visualizable, here I go with default of 2, so it's a planar thing. Then you have the centers. So this method or this function is going to generate for you a bunch of clusters with specific centers and specific standard deviations. And again, the default number is none, and the default standard deviation is 1. So for centers, you can either pass them the number of centers, like, hey, I want 2 centers, or like me in this case, you can provide the location of the centers, each one as a basically pair. And then you can provide the standard deviation. So here I have 2 samples. One of them I gave 0.5, the other one gave 1, right? So you can again pass it as a vector. And then you can have a bounding box for each one. You can have it to shuffle the data. You can have it to generate completely random state or none. The default is none. Do you want it to return the centers? The default is none, and then it returns for you the data, the labels, and the centers. And since our job here with k-means is to determine the labels and the centers, therefore we don't want it to return any of these. We just want it to return data. So you see, when I call this function with the 1,000 data points, with these centers, with those standard deviations, and I don't want any random state, I get the data stored in X, and then everything else that it wants to return, I don't want it. So I just use a basically underscore, so I don't care about those. I just want the data. So I get my data, and now here I'm going to apply the k-means method to this data, but using a different number of clusters. You know, the most important parameter in k-means is the number of clusters that you have to provide. So here I go from 2 clusters all the way to 9 clusters, and I'm going to show you how it is going to fit those clusters to the data. I calculate for you the cost function for each number of clusters, which in Scikit-Learn we call it inertia. And in my video that I talked about k-means under machine learning playlist, I call it the distortion method, J. So this is basically sum of the square distances of each sample to the cluster that they belong to, adding it over all clusters. And the important thing is you have to know that as we make the number of clusters more and more, then overfitting can happen. So here we're going to look at the plot of the cost function versus the number of clusters and see if there is any elbow point in it, so we can come up with an optimum number of clusters here. And that also I mentioned in my video in the theoretical part. So here, as I said, I have these sets of number of clusters, so I'm going to apply the k-means 8 times, right, from 2 clusters to 9 clusters. And here I'm going to store my values for the cost function in this vector that I started at 0, and I call it inertia val, or vals, you might call it. The other thing I do here, I create a figure with 8 subplots, and each subplot of it is going to be one of the results or the visualizations for the k-mean. And then I go in a for loop from 0 to the number of data in this one in range that. So this is 8, so it goes from 0 to 7. So you're going to repeat this 8 times. And the way that you apply k-means is by calling the command k-means, pass to it the number of clusters. So you see here I'm getting the jth entry or jth entry of this guy here, where j starts at 0. So first I get 2, then I get 3, 4, and so on. So that is going to be my number of clusters. I don't want any random state. This function by itself is going to create an object for me. This alone is not going to give me any results. It just creates an object. Now that object has a method called fit. And then I say, hey, that object, I want you to fit this data x. So apply your fit method, that object, apply your fit method to my data x, and then it is going to return something called whatever you want. Here I call it algo for algorithm. You can call it whatever you want. And this guy has some outputs. This guy has some fields, some data that you can get. One of them is the cluster centers. So if you want to know where are the cluster centers, you can get it by dot cluster centers, and then after centers, pay attention, there is another underscore. So cluster underscore centers underscore. This is one of the fields of this algo. So I get it and I call it centers. And then what I do here, I go to the jth axis or the jth subplot of my figure, and then I apply the scatter plot here. So what do? I show all of my x data, feature 1, and then all of my x data feature 2, right? So index 0 and index 1. So I plot all of my x data in a scatter plot. I use the marker size of 10. And then for the color, I use what? The algo.labels. This is the second output of this k-means algo. So one of them was centered, the other one was labels. So this labels is going to be any number from 0 to the number of clusters. So if number of clusters is 5, then this label is going to be a matrix that involves numbers 0, 1, 2, 3, and 4, right? Because I have 5 clusters. So it gives a number 0, 1 all the way to n-1, where n is the number of clusters. To each one of those 1000 data, it tells you which one of the clusters that data belongs to, or which one of the data centers that one belongs to. So you see I'm using the same color for what? For the same group of data that have the same labels, right? So if my data all have label 0, I'm gonna color them one color. If the data have label 1, I'm gonna apply another color. That's way I make sure I have all data in the same cluster with the same color. On the top of that, I show you what? All of the centers that this method found for me, and I assigned it to the variable centers. I'm going to show all of them with the red color with a bigger marker size. So on the top of those colorful data, I'm going to show you the centers in bigger circles red. And then I'm going to add a title, which is going to be k equal to one of these numbers. You see here, I get the n cluster list jj. I convert it into string. This is typecasting. And then here, I'm adding k equal to 2, that the string. So here I'm doing concatenation of strings, right? I can use comma instead of plus. I'm adding 2 strings together. So this is a total string, like k equal 2, k equal 4, k equal 9, and then I use that as the title for the j subplot. I also, another thing that you can get, remember 2 outputs so far were labels and cluster centers. The other thing you can get, or the other 2 things you can get, is one of them n iter underscore, and the other one is inertia underscore. So this inertia is the cost function, the total cost function, and this is the number of iterations it took the algorithm to converge. Okay? So the other thing I want to show on the screen is I show you that, hey, k-means converged in 5 iterations to an inertia of what? To an inertia of 3, or to an inertia of 500 or 600, or these are a little bit bigger numbers. So k-means, and I can add something for you with a k equals, and then here, and then I can add this guy for you as well. So it shows you for each k, I converted to what, right? K means with the k of something converged to this much of inertia in so much iterations. So this is going to show you per number in the loop. This is going to show you how many iterations it took for those number of clusters and how much was the cost function. And you'll see as this number of clusters go up, this inertia goes down, and that is the danger of overfitting, because yes, of course, the more clusters, the more chance of bringing down that cost function at the price of overfitting. And here I'm going to plot for you this vector versus those inertia values that I have stored. So with all that said, let's go ahead and run this whole thing so you can see it better. So here we go. This is my these are all of my subplots for k from 2 all the way to k of 9. And you see here I made my clusters such that they are separate, because I used in the standard deviations, one of them half, one of them 1. And then my centers, if you remember, they are where? My centers, one of them is at 1 and -2, the other one is at 3 and 4. So 1 and -2, right? And the other one at basically 3 and 4, right? So it exactly, you see, it converged to my centers very accurately. These are the centers I gave to the blobs method, and my k-means very accurately converged to them. But now, because that was 2 clusters and I used 2 clusters, everything perfect. Now, if I say 3 clusters, it tries to break this bigger cluster into 2. If I say 4 clusters, it breaks this bigger one into 3. If I say 5, now it starts breaking the smaller clusters, the bigger one, the smaller one, the bigger one, and so on and so forth, right? So you see that it is trying to basically add more clusters, which is not necessarily super meaningful, okay? So this is your overall cluster data. You see each cluster has its own color. And then this is that plot that I said, cost function versus the number of iterations. And you see that around 4, I have a quite bit visible elbow. So maybe k of 4 here is good, although to me k of 2 is the best one. But clearly after k of 4, I have a drop in the slope of the cost function. So maybe I can call k of 4 the best cluster. And you can play with this and change anything that you want. So you can add more clusters, you can add more data points, you can add change anything, right? And you can play with this and learn how this algorithm is working. Another thing I wanted to show you is, as I said, label is one of the outputs. Now, if in this case I say print for me the labels, algo.labels, well, guess what? You're going to get a matrix of 1,000 data points, 1,000 labels, right? And that is going to be a huge matrix. So I'm not printing it because I don't want that huge thing to show on my screen. And the other thing is the prediction method. And the prediction, you can now pass to it a new data, which is not necessarily in the blobs, and say, hey, for this data or these data, tell me which class of the data they belong to. They belong to which center, okay? And I'll show you that. But before that, let me show you the results on the screen that I mentioned. So here you see it says for k of 2, it converges in 2 iterations. This is the total cost function. For k of 3, it converges in 10 iterations. This is the total cost function, and so on and so forth. And you see it is going down continuously. If you look at the last number, the cost function, you see it is dropping from 1180 all the way to 320, 9, but you see that here the slope is like every time it goes by 2 or 300, but after this k of 4, you are now down to 100, less than 100, and then here you're down to like 50, 60, and so on. So the slope, the intensity of the drop is reduced by the increase in the number of clusters, and so after some time you are basically just overfitting. Okay, so here is this output that I showed you. Now let me show you that predict. So here you can say, for example, let me go ahead and just use 4 clusters in this case instead of let's say 8. And then here we can also go ahead and predict some data points. So let me first show you the results of 4 clusters, right? So this is the result for 4 clusters. And then here, let's say we have some data point, and we want to see where that data point belonged to. So here, the last k that I have tried, so my algorithm at the end of this for loop is for k of 5. So here we go with k of 5, and we assign some data points and see where they belong. So let's say here I go with the data at 2 and 0, right? If I have a data here at this cursor, where does it belong to? So here I change it to 2 and 0. Then I say I have a data maybe here, right, at let's say 6 and 2. And where does that data belong to? And then here I say, let's say I have a data at 1 and 6, something here. What does that one belong to? Okay, and here we can go ahead and get this class of new data from running the algorithm. So let's go ahead and run that, and it is going to show that also on the screen for me. And as you can see, it says class 0, class 1, class 4, right? And clearly, if you look at the data, right? So 2 and 0, class 0, right? 2 and 0 here. So this guy should be class 0, this purple one. And then we have also class 1 and class 4. 1 is for 6 and 2. So it is here. So this should be class 1, and then class 4 is for 1 and 6. So this guy is what? Class 4, as you can see. Okay, so by the way, it's not perfectly ordered. So it's not like, hey, this is 0, 1, 2, 3, 4. It's not like that. You see, 1 and 4 are right next to each other. Okay, so it's not perfectly ordered. And this is how you can predict where each data point, which class of data, which cluster of data it belongs to. So you have seen the outputs, you have seen the inputs for both make blobs and the k-means, and you've seen something about the overfitting. So hopefully this video was useful to you, and I'll see you in my next lecture. Thank you.